Hi there. So we have a cell site is a site where electronic communication equipment is placed in a cellular network for mobile phones. The numbers of cell sites, Y, from 1985 to 2014 is modeled by this equation. Use the model to find the number of cell sites in the years 1998 and 2006. Use a graphing utility, which I will let you do, below to graph the function. It's just plugging that in. You can use the GeoGebra link on the previous page. There's nothing wrong with that. That's why it's there. And then determine the year where the cell sites reach 270,000 and use your graphing utility to kind of confirm that they're about the same. Okay, so first up, we did something similar to this in the notes, right? We want to look at these 2 years. We have 1998 and then we have 2006. And what we need to figure out is how many years have passed since whenever we started the count. And so that is where this information comes in really handy, right? I guess all the way out to here. T is equal to 5 corresponds to 1985. So T would be, and then will correspond to the year. So 5 would be 1985. That means that 1980 is year 0, right? Or when T is equal to 0, when the count started, so to speak. So 1998, you would just subtract. So that means that's 18. And that means, let me scoot down, 2006 would be 26, right? So for the first calculation, we're going to find when T is 18, what do we get out of this equation? And then second up, we're going to do it when T is 26. Let me scoot down a bit. I know these questions take up lots of words. The good news is you don't have to write any of this down if it's a test or anything like that, right? You're welcome to show the work. I don't need the question written down. So our equation, let's call this A1. We're looking at Y is equal to 320,110 divided by 1 plus 374e to the negative 0.252 t. Now, instead of t, though, remember, I'm going to put an 18 here. And just like many of the questions we've seen in this section, a lot of this comes down to simplifying, right? So I need negative 0.252 times 18. This portion right here is going to be negative 4.536. And then we want e to that answer. So e to that is going to be 107161857 times 374. So from here over is going to be 4.007853445 plus 1. So we're going to end up with, let me go back to pink here. Y is 320,110 divided by 5 point, I didn't add my 1 in. 5.007853445. And this gives us Y is approximately 63,921.59905. So remembering again, this is representing cell sites. So again, it should be a whole amount. So you can say Y, I'm gonna round it down because again, it wouldn't, this isn't quite a whole number to round it up to. You can, again, as long as I can follow what you're doing, if the directions are unclear, as long as I can see your process, you're good. But if the directions say to round a certain way, make sure you do that. So 63,921. So this would be cell sites in 1998. Okay, we're pretty much going to replicate this process, but now we're going to use 26 instead. So let me call it A2. Y is equal to 320,110 again, right? Divided by, scoot it, 1 plus 374 e to the negative 0.252. This is a 26 this time. Okay, so this time when we multiply, we get a negative 6.552, and we want e to that answer. So this portion, let's scroll up more. I get 0.0014272582 times 374 gives us 0.5337945763 plus that 1. Don't forget, let me rewrite the equation over here. So you've got y is 320,110 divided by 1.533794576, right? And when we divide that, so 320,110 divided by that last answer, we end up with y is approximately 208,704.6108. Again, we're talking cell sites, so I'm going to take the nearest whole. So y is going to be 208,704 cell sites. Should have spelled that with an S up above. I'll fix that. In 2006. The next thing you're supposed to do is use a graphing utility. So again, you have that GeoGebra graph. Take a moment and just type this in. When you do this, I do recommend that you use an X and a Y instead of a Y and a T. So Y can stay itself. Swap the T out for an X because not all of these digital graphing tools will understand what T means. And make sure you zoom out correctly. So it should look mostly exponential. It's got kind of a weird curve to it, but you should get a curve in there. And then the last thing we were asked to do is use this graphing utility to find the year where it's at 270,000 cell sites. So what we want to do, so this will be part C, so I'll say B, use graphing tool. Part C, what you want to do is set that 270,000 equal to the rest of your question, right? So equal to 320,110 divided by 1 plus 374 e negative 0.252 t. And our goal is to solve for t. So we saw a similar question to this when we were doing our notes, and we saw it just takes patience and caution, right? Do not try to rush through these. So I'm going to use that same reciprocal property. I'm going to take the reciprocal of both sides. So I'm going to say 1 over 270,000 equal to 1 plus 374e negative 0.252t divided by 320,110. And then I'm going to multiply by my denominator, my new denominator. So that cancels. Honestly, I'm going to worry about reducing this as a fraction later. It's all going to end up on a calculator, so there's maybe a little more flexibility than a normal question. You can cross out a 0 if you want. right? Make sure everything gets copied correctly from one layer to the next. We're going to subtract 1. And again, for the sake of this being really clean, it might be something that just gets thrown into a calculator. So I'm going to put divide by that 374. So again, you might want to start putting things on a calculator now. It definitely depends on the kind of calculator you have and your comfort levels with it. I am just waiting till the very end to put it all in. So I've got a really ugly double fraction, complex fraction, 32,011 over 27,000 minus 1, all divided by 374 equal to e to the negative 0.252 t. And I'm going to introduce an ln on both sides. These actions undo each other, so we're left with ln of this mess. You can get a common denominator there if you want, but again, not sure it helps the problem along much. And then I'm going to divide everyone, let me go back to purple, I'm going to divide everyone by negative 0.252. So you have quite a bit to throw into your calculator. Let's go through some of that now. So this first fraction, so 32,011 divided by 27,000 is approximately 1.185592593. If we subtract the 1, that gives us approximately, again, 0.1855925993. And then I'm going to divide that. So that part's done, that part's done. I'm going to divide that by 374. So divided by 374. Except for I wrote 370. Approximately 4.962368786 times 10 to the negative 4. Again, I'm not as worried about moving that over because it's going to go into another equation right now. If that was my final answer, maybe. I want to find ln of that. So ln of that. Again, make good use of your answer button here, right? You do not need to retype these. If you're using a phone, you have a copy and paste function. So ln of all that is approximately negative 7.608457167 divided by, last step, so this is done, that's done, divided by negative 0.252. Final answer, t is approximately 30.19229035. Okay, so remember we went backwards this time, so this is years, right? So the years since 1985, right? 1980, excuse me. So about 30 years later, 1980, if we went 30 years later, that'd be 2010, right? So there will be 270,000 cell sites in 2010. Whew. Again, the new math is not so bad. It's just an equation. We're just plugging stuff in, right? The stuff where it gets more complicated is all the simplification. And you really do have to be accurate with that. I know a handful of you have run into some issues with rounding. Make sure you're accurate on that, right? and reach out if you run into any trouble, or visit tutoring if you run into any trouble with that.